Okay, so what we're going to do is we're going to use one procedure. It's referred to by two names. It's sometimes you'll see it referred to as from first principles, and the other one is by the definition. So we want to find the derivative. Now the derivative, here we've got a function, y equals 3x squared minus 5. And if you like, there's a bit of background here. We've got y equals 3x squared minus 5. So y equals x squared is just our parabola like that. 3x squared is a steeper one, so it'll come inside y equals x squared, so it's quite steep. So that's y equals 3x squared. And y equals 3x squared minus 5, the minus 5 just moves us down 5 units. The same graph can be drawn here. So that's y equals 3x squared minus 5. And we were saying that the derivative is the gradient at any point on this graph. So at any point there, we will be able to calculate the gradient. The gradient is the rise over run. Now, you say, well, how do you get a gradient to a curve? Well, what you do is, say we were interested in that point there, you draw what's called a tangent, and a tangent is a straight line that just touches the graph at that point, and it only touches at one point. It's a very particular line. It doesn't cut it twice, it just cuts that graph once, so that's a tangent. And if we do the rise divided by the run, and we can draw that triangle at anywhere because it'll all be the same underneath a straight line. So that rise, which we can see is going to be negative over the run, which is from there to there, will be the gradient of this curve at that particular point. So we say it's an instantaneous rate of change of y with respect to x at that particular point. Now, we can calculate at any point, and we'll do that at the end. So find the derivative of y equals 3x squared minus 5 from first principles. Two ways we can refer to this process: first principles and by the definition. So whoever wrote the question, me, decided to use from first principles. Okay, so we know y equals f of x, so we write it down first. Y is the same as interchangeable with function of x. And we know that that is equal to 3x squared minus 5. So we write that down. So this is part of the process, if you like, part of the step. So that's the first step. Second step is to write f of x plus h. So f x plus h, and our work before with functions, you know that everywhere there's an x up there, I'm now going to put an x plus h. So that x will be replaced. You have to put it in brackets. That's my pattern of this function. But we haven't got x here anymore. We've got x plus h, so we've got x plus h. Now, I think it's probably a good idea to expand that out. So we get no brackets. Now, what do we do first? Do we do the times 3 or the square? Well, going back to BIDMAS, we've got brackets. So we're going to expand the brackets first, and index comes before multiplication, so we're going to use the squared. So we're going to do x plus h squared, so it'll be 3. Now x plus h squared is going to give us 3 terms. We use FOIL, x squared plus 2xh plus h squared minus 5 equals, multiply out by 3. Now that 3 is everything inside the brackets, doesn't apply to the 5, so that's 3x squared plus 6xh plus 3h squared minus 5. Okay, so that's f of x plus h. So they are the first two steps done in any of these. You write down, if you're only given y up here, we interchange y and f of x, and then we've got f of x plus h. So they're the first two steps. The third step is to quote the definition. That's why it's sometimes called by the definition. First principles is the same thing. So by the definition, you write those words, dy dx, that is the derivative, dy dx is the derivative, equals, now you've got to remember what it was, and we went through this before, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Now that's what the definition of the derivative or dy dx is. And what is dy dx? It's the instantaneous rate of change or the gradient at any point on the curve. And the curve is, in this case, 3x squared minus 5. Okay, so what do we do next? We've got our f of x, so we can substitute in for f of x because there it is up there. And f of x plus h, we've actually got it and simplified, and we've got it up there as well. So instead of f of x plus h, now we keep writing limit until we actually do the substitution. We can't put h equals 0 in there because we get divisibility by 0. So we're going to have to do some factorising and cancel that h out before we can do any substitution. So you've got to keep writing this, the limit as h approaches 0. Now instead of f of x plus h, we write all this long sucker here, 3x squared plus 6xh plus 3h squared minus 5. That's f of x plus h. Now it's minus f of x. Now it's minus this. And if you've got a minus with this in brackets, means that minus in front of the 5 up here is going to change to a plus. So if you've got a minus in front of that, so rather than have to write the whole thing again, it's minus 3x squared. And if you imagine the minus there, this minus in front of the 3x squared with brackets, and you've got minus 5, when you remove the brackets, this will become a plus 5. All right, so I haven't cheated, but I've done 2 steps in the one there, two lines in the one. I hope you can follow that. And this is all over h. Equals. We're still not in a position where we can put h equals 0 because we've still got divisibility by 0. So we keep writing this limit as h approaches 0, and it's going to be all over h. Now, let's see if we can cancel some things out. Let's use a red one for that. So we've got 3x squared there and 3x squared there. So 3x squared minus 3x squared is 0. So we can cancel those out. What else can we cancel? There's no 6xh, there's no 3h squared. Oh, we've got a minus 5 and a plus 5, so they will go. A little hint. When you do the cancelling here, all the terms that are left must have a h in them. Okay, always will, no matter what it is. So just check for that. If you have done all the cancelling and you've still got something here with just x's and no h in it, you know you've made a mistake. So go back and have a look back up there. All right, so we don't need a line that big either. So we've got only 2 terms, 6xh plus 3h squared. Okay, still can't, because we put h equals 0, we've got 0 plus 0 over 0, so oop, can't do. So we still write this limit, h approaches 0. We can factorise and take h outside the front. 6x plus 3h all over h. Now we can cancel this h with that h. And now we can go and substitute in. Whoops, we get back to our black pen. So now we can go back and put h equals 0 because we're no longer dividing by 0. It's the limit as h approaches 0 of 6x plus 3h. Well, that is going to be, if you put h equals 0, 3 times 0 is 0, so you get 6x plus 0, so it'll be just equal to 6x. Okay, so what does that mean? That means that given an x value at some point on the curve, okay, and now let's have a look at this. Just say this is the point -1. Okay, and that corresponds to this point down here. X equals -1. At that point, because dy dx is equal to 6x, at x equals 1, -1 it is, x equals -1, dy dx equals 6, x is equal to -1 times -1 equals -6. So my rise divided by my run, obviously I haven't drawn this tangent too well, because this will be 6 times as big as this will be if I drew that accurately. And this is what a gradient, -6 gradient is -6 over 1. So it drops 6 for every one it goes across. I just chose -1. Say I wanted x equals 2. What's the gradient of the tangent, or the gradient of the curve at x equals 2? dy dx is equal to 2 times at x equals 2. It's 6x, so 6 times 2. It should have 6 times 2, eh? 6 times 2, so that's equal to 12, which is equal to 12 over 1. That means at x equals 2, so you can see how this is getting very steep. But at x equals 2, for every, I can't even draw the tangent there, for every one across, it's going to go up 12 units. So my y quantity, at that point at x equals 2, my y quantity is going up 12 times as quick as the x quantity. And that's the power of calculus, and that's the power of the derivative. It actually allows us to calculate instantaneous, not average, instantaneous rates. Because this y equals 3x squared minus 5 might have been, this might be litres and this might be minutes. And so we're measuring the dy dx will be the flow rate in litres per minute at any point. So at t equals 2, at 2 minutes, we could work out what the flow rate is. All right, so what we've done here is just gone through the derivative from first principles, or sometimes called finding the derivative. Derivative is dy dx, finding it by the definition. It's a long-winded approach, but I think it helps you understand exactly what the derivative is, and it's a gradient of the curve at any particular point.